just a brief introduction, and then I'll share my screen and we can look at that together. So I think the module that I put together, I've been collaborating with Kieran as our two modules have worked. And so this is maybe a unique thing of our contribution to HydroLearn is that we actually have a very clear cross-linkage between modules in which the capstone activity in Kieran's module is one way that you can think about a solute tracer. And within my module, we'll give the briefest of introductions to the storage selection work. And then students will be directed to his module if they want to really dive into that topic in a more deep way. So we're starting to not have modules just be sort of pick and choose, but actually building connective tissue in between them. So that's maybe one of the unique goals that Kieran and I have been working on, is figuring out exactly how we do that and what's enough knowledge to take them as standalone, but still highlights the complementary nature. So, so with that, I'll share my desktop here and just give sort of an overview of the module I put together. This module is targeted, in my mind, towards something in the upper level undergraduate, so a 400 level class that might be about water quality or environmental transport. That course is probably most commonly offered at the 500 level, so thinking about master's students, occasionally doctoral level, or this might be a place where a student or a consultant who wants to perform a tracer study, wants to learn about transport and fate, would come and just work through this on their own without it being facilitated by a classroom-based instructor. So a goal for me is that someone can work through this module without having a in-class facilitator. So from that perspective, I record videos of myself and design assignments as though I am your instructor, and I'm guiding you through this tour of how to be successful here. So the goal of this study, used to research talks, the goal of this module is really to walk people through understanding some of what you can learn. Why might you need these data? How do you collect the data in the field? And how do you interpret those data to some meaningful descriptors of things like dispersion or late time, long-term legacies of pollutants in environmental systems? We explore this through stream tracers, though in the beginning of the module and end of the module, I try to make the point that this is one application of these concepts, but this maps almost perfectly to pollutants in the atmosphere, to accidental spills in groundwater systems. The underlying concepts are very similar. So the overarching goal here, and really the main thing I want people to be able to do, is say, okay, now I have enough context to go collect my own data and interpret my own data. And through the module, we teach those skill sets. So the module is, oops, wrong way. So the module is broken down into really 6 major elements. An introduction, sort of the what are we doing, why are we here, what good is this module to me? We work through field methods. So how do I plan and execute an experiment of this sort? That's item 2. We work through then 3 sets of calculations. So 3, 4, and 5 are sort of different ways that you might interpret your data depending on what you're trying to learn from this experiment. And then the 6th topic is reactive transport. So adding into this, what about a solute that is not simply being transported, but it's also reacting as it moves? And I have taught, the design of this module is based on a short course that I've taught several times. I've taught that course as sort of an intensive 6-day or 6-lecture experience for students, I suppose. And so what I've done is basically take what would have been, a half a day of instruction and discussion and compress it into each of these 6 modules. So if you were teaching this in the classroom and you had students going through this as part of a 3 credit hour class, I would expect each of these modules to be 1 or 2 lectures long. So this is anywhere from 3 to 6 weeks. And the difference would be how much depth that you might want to go into, or if you want someone to work this themselves, you might be on the light end of that. So 1 module per 1.5 hour lecture. If you want to add some extensions and do some relating of it to content you've covered earlier in the semester, or to tee up something you will get to, then this is probably potentially 6 weeks of lecture time. Okay, so that's the overview. The sort of motivation and one of the authentic tasks is based around the Gold King mine spill that some of you may remember happening a few years ago. This is on the Animas River out in Colorado. And so this is motivated with a nice short clip from CBS giving an overview of what happened and what it looks like when there is a massive spill. And the image you can see here is one that I think is really important because it shows how many towns are downstream, and it shows the timing of when the plume is starting to be seen at these towns. And so we're motivated by questions like, if I'm running the public water supply down here in Durango, when do I need to shut off the water supply and have the National Guard be trucking in water? What's the worst case scenario? So what's the peak concentration if I'm worried about toxicity for the ecosystem? And when can I turn my water supply back on? How long are we operating with bottled water? So those are sort of the authentic task, or the motivation to understand. So I've grabbed some of my favorite images from over the years to try to motivate the questions that people will be looking to you as potentially the city engineer or the local expert to answer. So that's why we're here learning. Through the module, then, the data set that Kieran provided for the Solute tracer study, his capstone, is the identical data set and site to what our students will work with here. So as you work through learning activities in this module, you're building your own toolkit, and you're then getting access to a toolkit that I've built. So as you progress through the module, you're doing the calculations yourself in Excel, for example, and then you're accessing my version of it. That way you know if you've done it correctly or not. So it's not just use my tool to do your work. It's build a tool so you understand it. You can check your tool against mine and know that you have something robust that you can then carry forward for your own analysis. So each learning activity, the first one goes through quite a lot of the field experiments so people could see what was done and where it was done. Data sets for students to download. So you've got just the raw data to work with. And each one of those 6 modules follows a very similar pattern. If we zoom in on what happens inside of a module, so this is inside of the study design where we want to actually learn mixing lengths. Each topic that I teach is basically a kind of a 1-2 punch, if you will. The one is a short clip of me doing the lecturing, and my voice is not nearly as soothing as Kieran, so I won't turn the volume on here. But these videos are recorded using a piece of software called Doceri, and I'll type that in the chat box in a bit. So I pre-record these and narrate over them. So this is essentially 10-minute lectures from me on a topic. So students would work through, basically watch this lecture video. Each of those has any key references that I've cited. And I'm also pointing towards supplemental resources. So, hey, are you super excited about mixing lengths and you want to learn more? Here's a paper that used multiple sensors to check this out. So throughout the module, I'm linking people to places where they could choose to go deeper if they want. So the 1-2 punch, that's 1, I lecture on it. The 2 in that 1-2 punch then is, oh my goodness, can I navigate my own module to find an example now? So the 2 is then And of course, I clicked on one of the smallest and easiest ones here. But the 2 is basically, okay, you saw me do it, now implement it. You saw me do it, now implement it. And so we're sequentially showing students 10 minutes of content, they do it with the data. 10 minutes of content, they do it with the data. And then at the end of each day, there's a broader synthesis topic that's questions are something like, okay, now let's think about what you've done in this module and how it relates to that Animas River spill. Based on what you did here, which might be the most valuable? Which are the pieces you would think are important to decision makers or in an emergency response context? So that's hopefully that's giving a sense of how this module is designed. I'm about halfway through the content creation. I haven't uploaded it all onto HydroLearn yet. Yeah, that's the game plan, is to have that sequence of short videos and then very targeted implementations. So you can't get overwhelmed by too many different topics. You have a very focused piece to work through as you move on. Okay, that's what I wanted to share, and I guess I'll look over here in the chat. Imad says we should let people know that these are great for self-guided on the About page. Yes, absolutely can do that. Do I have a YouTube channel with the videos on this topic? So I do have a YouTube channel with some of these videos, and I'm slowly transitioning all of the videos that I've ever recorded for every class I've taught onto that channel. So let's see if I can find it. Can I find it in a timely fashion? I will certainly share it as a stopgap. My own website has some video players of videos I've done on different topics. So my normal, I teach my face-to-face classes the exact same way. I record short videos. The thing that you lecture on for 10 minutes every year on the 3rd day of class, I don't do that anymore. I record that once and do a decent job of it, I should say. And then I spend our class time on extensions, discussions, practice problems. So on the link that I just shared, it doesn't have all the transport and fate stuff yet, but you can see there's something like 100 videos on there that span fluid mechanics and water quality modeling topics. And those are not all hosted on YouTube yet. Some are stuck inside of a proprietary purgatory from my university. But with COVID, I instantaneously now own the rights to the online education material I produce. So I'm moving it all into the public domain before they take that back. So that was a long answer to a question of, yes, I'm totally happy to share, and it will all end up on YouTube. And I think Melissa and Imad and others would be happy for me to remind everybody, HydroShare itself is open source. And so you could hop into HydroShare in these modules and always find the videos that way too. But great idea to add that YouTube channel or that YouTube playlist to the front end that just says, hey, if you want it, here it is. Also, all the slides that I'm writing on will exist as a PDF file, so students can grab that and take their own notes, which is my very first video of what should you do, is you should download the PDF slides and take notes for yourself, because that act of writing can be really important for some people's learning. What else? Yeah, David. Yes, Dave. Print. Yep. So I suggest to folks, I'm old school. I suggest they print the notes out on hard copy and write on it by hand. But I know other students like to do that stuff digitally. But still, it makes it active versus passive learning. And so I really strongly encourage students, when I show these kind of videos, I give them the slides and really strongly encourage that they actually take notes as though they're in lecture.
There's actually a pedagogical practice where the slides you give the students, you leave blank. And so those blanks will be in your slides and you're presenting and you'll say the words, but so it forces them to attend even more because they're looking for those blanks you've left in their notes.
Yeah, so that's a good idea. I don't, so the slides that I give them don't have any of my handwriting. So they're just the blank slides. The one that you all saw was just a blank slide with me doodling. But sometimes there's photographs, or I'll have two sets of axes with the labels, but not the lines on them yet, to try to do that. And then just as a little bit of a pro tip, having done this style for some time, um, at the top of my slides, the topics are color coded. So like all the slides that have a purple bar across the top, I think those go together. And then when it switches to a yellow bar, it's because we're switching to another topic. So it's a way of helping students outline. Um, and I didn't show you guys this, but there's a video number 1 which says, how am I supposed to learn from this? With my suggested way of doing this, and I talk about why the bars are color coded on their slides. It's not random, and it's not me being funny. It's intentional. So I think that's a thing that I'm quite proud of, is actually adding a little guide to help remind students. Dave suggests color coding for different topics. Yeah, there was sorry, I know I'm at the end of my time here. I'm using every last second. Buckle up. We're doing this. There was a project a while, maybe 7 years ago, called MOCA, which was Modular Curriculum for Hydrologic something, something clever with an A for the acronym to work. They had an organizational structure that had like theory, field, model, and then scales. I think it was like local scale, regional scale, continental/global scale. And they had a little icon down in the bottom right corner to help people key into that, Dave, as well. That's more complicated than I'm willing to deal with in this moment. But the spirit of it is the same, right? Helping the learner understand how this piece fits. And so color bars at the top or little icons. I hadn't seen it yet, but I like how Kieran used the titles to help people know which thing is being asked of them. Especially for distance learning, I'm finding that's been really, really helpful to students because it helps clarify expectations. All right, my clock now says 4:30. I better zip it.
All right. Well, thank you so much.